Okay, so in this video, we're going to take our full adder, and we're going to create a block design, and we're going to add the adder to the block design. Then we're going to add some Xilinx IP that does the same thing, and we're going to compare the results. We're going to export everything again using a design checkpoint. So as you can see, you just drag the VHDL file onto the block design. I'm going to use the adder subtractor IP. This IP is going to require some customization, so double click on it. We're going to keep things simple, so we're going to make everything unsigned and 1 bit, also known as a Boolean. We're not going to use the clock enable, so we're going to go to the control tab and disable that, but we are going to use carry in and carry out. Now, if you right click on the port of some IP, you can say make external, which will create either an input or an output port. So now I'm going to create 3 inputs. I'm going to rename them to make them match what's in my VHDL code. It's very simple. You just click on the port and go to the properties dialog box. A in, B in, C in. Then for the output, I'm going to have S out VHD, C out VHD, and then for the IP, instead of using the VHD suffix, I'm going to use the IP suffix. So I'm going to create a port, make external, I'm going to use the same input ports for both, except for the clock in, of course. Now the first button I'm clicking is rearrange layout. The second button is validate design. After you validate a design, you right click on it and you say generate output products. Again, this is very quick with the latest computers, especially for a small design like this. Okay, now that that's finished, I'm going to right click on the design and I'm going to tell it to create a wrapper. So we have a design, we have a wrapper around that design. When we export this design from LabVIEW, we need another wrapper. So we have a wrapper that calls a wrapper that calls the design. It's important to remember that because I've lost many cycles where I forgot to create an extra wrapper. So here we go, create, where is it? Create HDL wrapper. If you make changes to your design, Vivado will automatically update the wrapper. We're setting the wrapper as the top. Okay, and now we're going to run synthesis again, which should be outdated because we did create a block design and all that other stuff. We're going to make a new folder in our LabVIEW project, import design DCP. We're going to copy that directory to the clipboard. We're going to wait for synthesis. It's important to open the design after you create it. Because if you say write checkpoint and you haven't opened the design, you may get just a checkpoint without the synthesis in there. Again, if you run implementation and you do not open the implemented design and you say write checkpoint, you're not going to get the implemented version. You're going to get just whatever was open before that. So now we're going to write the checkpoint. We're going to put it into this new directory, import design DCP, and then we're going to go to we're going to go make our wrapper of a wrapper. So again, I've pre-written this code. I'm just going to paste it in. But the file, design1 wrapper wrapper. Notice how the entity, design1 wrapper wrapper, it uses a component, design1 wrapper, and the design1 wrapper uses design1. Now again, LabVIEW, IP integration node. We're going to add the two files. VHDL set as top, simulation post synthesis, limit the FPGA family, check syntax. If you ever get the error message that occurred here, sometimes you have to click check syntax twice. I see elaboration is running, so I think it's going to succeed. Yes, it did. Now we're clicking generate IP. This time we are using a clock, so we specify the port. No clock enables. Nothing else. Everything's a Boolean. And again, we're going to create a bunch of controls and indicators. But this time we're going to have the output from the IP that we wrote in VHDL called the full adder, and from the Xilinx IP adder subtractor. We're going to run it, and the output looks good. All right, thank you for watching.